Hello everyone. Today I will be talking about Java programming topics. And the topics that I will be covering today are classes, objects, what is a constructor, inheritance, overloading and overriding, static fields and method array, final constant, format specifier, polymorphism, abstract, interface, encapsulation, access modifier, file input and output. I will try my best to explain each of these concepts, and I will also provide examples and sample code so that you will understand better. And the first one that we'll be getting started with are classes and objects. And a class is a blueprint from which objects are created. And the example that I want you to think about it is about a blueprint. The blueprint resembles a house, a class. The blueprint of a house resembles a class. And an object is an instance of a class. And remember that objects have states and behaviors. And the example that I want to go back to again is the blueprint of the house and the actual house. And when you build the house out of the blueprint, that is the same as an object being created from a class. And here in this sample code, you can see the example that I provided. And here I'm creating a class that is called house. And I also provided with variables inside of the house, the member fields. And you can provide many. I have string color and number of rooms, string location, and these are states, states of the house, of the class house. And I also provided with some functions inside of the class house. Here we have the first method called house color. The second one is house rooms, and the third one is house locations. And these are all behaviors. And over here in the main method, I have the instantiating of the class, and here I declare my object, and my object is an instance of a class house. So this would be the actual built house, right? And then over here, the class would be the blueprint. And you can create many different objects out of the same class. Moving on, we have constructor. So a constructor will have the same name as the class name. And over here, if you take a look at over here in the sample code, we have the class house, and over here I have a function that has the same name as the class, and this will be the constructor. And the purpose of having a constructor is so that you initialize the newly created object. And here I initialize the values, which are color, number of rooms, and location using the this pointer. And you can take a look at the rest. Over here, my object is an instance of the class house, and I sent in the values blue for color, 4 for the number of rooms, and north as the location. And moving on, what is inheritance? Inheritance is a very important concept in Java, and it is when a class inherits commonly used fields and methods from another class. In this case, the parent class is called a superclass. The child class will inherit the features of the superclass, and it is called a subclass. The keyword extends, right here, or extends, is used by the subclass to inherit from the superclass. And here in this picture, there are multiple examples of inheritance. The one that I will be covering today is single inheritance. And you can see here that the subclass will inherit the fields and methods from this superclass. And here is the sample code. Here I created a class called animals, and this will be the superclass or the parent class. And I also have this method called display, and the method called display says this method displays animals. And over here I have this cat class, and it will extend animals. So this will be the subclass, and here we see the keyword extends. This means that the class cat will inherit all the functions and variables from the animals class. And here we have also another function inside of the subclass. And then over here in the main method, I have an object from the cat class, which is the subclass, remember. And here we are instantiating the subclass. And And then I am calling the display method that was inherited from the superclass. And then over here, I am calling the display cat method of subclass. And again, this is an example of inheritance because I am calling the subclass that was inherited from the superclass. Moving on, what is an access modifier? An access modifier tells you which classes can access a certain class and its member fields, methods, and constructor. So here in this picture, it's very helpful and it will tell you basically everything. These are the modifiers. You have public, protected, default, and private. And here you have like the classes that can access that certain class. So basically, if you have a class that is public, you can access it from a different class, from a different package, from a subclass, and so on. If you have a class that is protected, you have the keyword protected, that is the access modifier. A different class can access it, yes. A package can access it, yes. A subclass can access it, yes, and so on. But take a look at the last one, which is private. So a different class, in this case, a different class can access it, yes, but it cannot be accessed by another package. And here at the bottom, I have different examples. Let's say that you have a class that is public. That means that it can be accessed from anywhere. And here in the sample code, I tell you how you can write it. So you can just put the public keyword there. And let's say that you have a class that has no modifier, and that means that it can only be accessed from the same package. From a different package, you cannot access it. And the sample code is, you just write the name like that, house. You don't have to write anything. Let's say that you have a class, and inside of that class, you have a member method that is private. Then the method cannot be accessed from a different class. And this is how you write that method, private void display. Moving on, what is polymorphism? Polymorphism is the ability of an object to take on many forms. And poly means many, and morphism means many forms. And here I provided with sample code. This one. We have a public interface that is called herbivore. You have a public class called animal. And lastly, you have a public class koala that extends animal and implements herbivore. And the reason that koala class is a polymorphic, is an example of polymorphism, is because it has multiple inheritance. A koala is a herbivore, a koala is a animal, and a koala is a koala. And here you can see that the koala object that we create can take on many forms. A koala object can be an object of an animal. A koala object can be an object of a herbivore class. And that is what polymorphism is. Moving on. What is overloading? Overloading is when you have two or more methods in one class that have the same method name but different parameters. And this is very important, different parameters. And here in this example, you can see that we have this class called division. And there are two member methods that have the same name. And you can see that it's called divide and divide. But the only difference is that you have different parameters. Here you have 3 parameters, int A, int B, and int C. And on the second one, you have 2 parameters, int A and int B. And these two having the same method name but different parameters is method overloading. And here it's when we run this code, basically it's going to send these values to the one with 3 parameters. And it's going to send these values to the method that has 2 parameters. And that's what method overloading is. Method overriding is when you have 2 methods that have the same method name and the same parameters, but one of the methods is in the superclass and the other method is in the subclass. So one is in the super, one is in the subclass. Here in the sample code that I have in the right is we have a class called superclass. That will be our superclass, of course. And this is the subclass. And right here, we can tell that this is a subclass because it has the keyword extends. And in this case, we have, as we had said, two methods that have the same method name. Same method, same method. And it also has the same parameter. So how will, when you call either or, how will it know which one to actually get the information from? How do we know that what we send in will get k plus 20 or k plus 10? How will we know which one? And it's very simple. The subclass method will override the superclass method. Right here, we are creating an object called SC1 from the subclass, right? And we're gonna call the method SC1 save method, and it will know that it has to get this method and not this one, because the subclass method will override the superclass method, and this is what overriding means. So here we are sending in the value of 7, right? So 7 plus 20 will be 27. So the output will be 27, right? Okay, so this is basically overriding, very simple concept. Moving on, what is a static field? And also I'm going to talk about methods, arrays. Basically, a static field in Java is a field that belongs to the class and not the instances of the class. So it's a variable that only belongs to that class. And no matter how many objects or instances you create of that class, the value of the static field is the same, right here, the same. And you can create a static field in Java by using the static keyword right here, static keyword in the field declaration. And here, this is an example how to declare a static field. You basically just put static int and then the variable name. It could be integer or any other data type. And you do not need an object to access static methods. You can just, this is in the main method declaration, and you can just put house dot rooms. House will be the class names dot rooms, and you can set that value of rooms to 5. So, and then once you run the program, you can no longer change that Java field. It will stay like that forever, because it is static and it doesn't change. And right here, you can also display that value, and you do not need an object to access it. You can just put the class name dot and then the name of the variable, and it will display 5 in this case. Arrays in Java. And I will just go over of the basics. And basically, an array is a group of like type variables that are referred to by a common name. So like type means that it has the same data type. So you can have an array of strings, an array of integers, an array of double, and they will be ordered, and they will have an index beginning from 0. So the first index will be 0, the next value will be 1, and so on. And here in this picture, this is a sample code of how you can write an array. So you can just put, let's say I want to create an array called my array right here, and I want it to be of the data type int. So I will have an array of integers. You can create it like this right here, write these two, and this will be the size of the array. In this case, I want the size of the integer array to be 10. So that's why I put 10, but you can leave it blank, and later on you can just initialize the size or add to the array. And over here, you can also do it this way, which you can write it all. You can compile these two into one line, and both will be the same. And here in the sample code, I'm teaching you how to read an array in Java. It's very, very simple. Here we have an array of integers that has 10 values in it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And if you want to read the array, you can use a for loop. Here I'm starting at I is equals to 0 because I want to access the first element of the array. And the first element starts with an index of 0. And here I have the I less than my array.length. And this, you can use this function right here that is already, like, it already comes with Java, and you can get the length of any array that you have. If you have 20 elements, you can just put that length and it will give you the length. And then I++, right, because of the for loop. And right here, I will start out by printing element at index I. And if we begin with the for loop, this will be 0. And then right here, it will display the element at that index. So it will be 1, right? And then 2, and then 3, and here, this is the output. And this is, but just remember that arrays start at index 0. Very simple concept in Java. Moving on. What is a final constant? A final constant is a Java field, just a variable, that is declared static and final. Once a Java field is declared final, its value cannot change. So no matter how many times you try to change the variable, it's not going to change. And this is very simple how to write it. You can just put static final int house rooms is equals to 8. And this is just an example. And it is very recommended that you write it in all caps. And that is a final constant. Very simple concept. What is encapsulation? Encapsulation is a very important concept in Java. It is the wrapping up of data under a single unit and preventing it from being accessed by code outside of the unit. Variables and data are hidden from other classes, and this is known as data hiding. How do you implement encapsulation? To do it, you basically declare all of the variables in the class as private, and you provide public setter and getter methods to access the variables. And here is an example of encapsulation and how it works. And it's a very basic sample code. Right here, I have a public class called grades. And to do the encapsulation, remember that I said that you have to set the variables as private. And this is done, private. Then you also have to provide public setter and getter methods. And here are the getter methods. So get midterm, get labs, get homework, and then the setters that also need to be public. So set midterm, set labs, set homework. And then over here in the main method right here, we have an object called obj1, object 1. And I'm going to use the setters from the class grades. And I'm going to set the midterm grade to 80. I'm going to set the labs grades for 100, and I'm going to set the homework to 100. And then to print it out, I can just use my get methods right here, and this will be the output. And this is the very simple example of encapsulation. Moving on. What is format specifier? Basically, you begin with a % character, and you end up with a type character. And that will tell you which data type the data will be converted to and represented on the screen if you choose to display it. And these are examples. So this will be the type character D, type character S, type character F. And over here I have %S. So that means that whatever I input, I want it to be converted to a string. And so on. %F will be for float, %X for hexadecimal, %C for char value, %O for octal value. And over here I have an example sample code so that you can understand everything. Right here I have this value 30, and I want it to be converted and displayed on the screen as an integer, so decimal integer, and that's why I put here %D. And now I have this word called hello, right? And it's a string, and I want it to be displayed as a string, converted it to a string, so I put %S, and so on for the rest. And here are the values after I run the program and I display So here you can see that the 189 will be converted to hexadecimal value. And in this case, it will be BD and so on. Moving on, what is an abstract class? And I know that this can be very confusing when you compare it to an interface because they're hard to kind of understand and to differentiate and know which one's which. But an abstract class is very simple. It is a class that cannot be used to create objects. You cannot create an abstract class, and you cannot create objects out of that abstract class. In order to access an abstract class, it must be inherited from another class. And I will provide sample code to understand this concept. An abstract method can only be used in the abstract class, but remember, it has no body. The body can be written in the subclass. And here I have a picture how it explains the abstract classes and abstract methods. Right here, I have this class shape, right? And I have the abstract int area method. And remember that because this is abstract, I cannot create a body. The body has to be done on the subclasses. And here I have different subclasses. This class triangle, class circle, class rectangle. And here is the implementation, the body of this abstract class. And moving on, I have another example. We have the abstract class shape. And I also have the abstract method right here, but it's only the header, it's not the declaration because that's one of the rules for creating an abstract class. Right here, I have this class called square that will extend shape. And remember that if you want to access an abstract class, you must do it through the subclass. And in this case, the subclass is the square class. I have this variable called int length in the subclass, and I will use right here I have this method called square using the length. This will be the constructor, my bad. This will be the constructor of the class, and right here I have the implementation, the body implementation of the abstract class over here. So this is why I'm actually using it. And then over here I have an object created out of the square class, the square class being the subclass, and I will send in the value for 8 for length. And then to get the area, I create a variable called int area, and I will store whatever I get out of this this method, and I'm just gonna print the area. So if I'm sending 8 right here, it's gonna multiply 8 times 8 times 8, and I will get the area of 512. But just remember that I am able to access this class by the subclass, and that is what an abstract class is. And you can, one of the rules for an abstract class is that you can only extend one abstract class right here. So you can only do one abstract class. And I will talk about why it's important when we're talking about interfaces, which is the following. An interface is very similar to an abstract class. An interface cannot be used to create objects, so that's why one way it is similar. Interface methods do not have a body. To access the interface methods, the interface must be implemented by another class with the implement keyword. Classes can implement more than one interface, and interface methods are by default abstract and public. Interface fields are by default public, static, and final. And remember how I was saying that only one abstract class only one subclass can extend one abstract class. And the difference between an interface and an abstract, one difference is that one class can actually implement more than one interfaces. And let's just talk about this sample code. We have this interface called shape, and I have this header member method, and I am able to use that and implement that member method right here. So this will be the body. Remember, we cannot put the body inside of an interface. And right here, to implement it, I put this keyword implements in right here. And over here, I have this object being created from the rectangle subclass. And I also would display calling this function right here. And the output will be area of a rectangle. Moving on, basics of Java file and input and output. And this will be the last topic that I cover, and I would only explain the basics of this. And the basics is that there are only two types of files in Java. We have text files and binary files. The examples that I will provide will be in they will be about text files. Files provide sequential and random access. Input stream and output stream are used to read and write 8-bit quantities of binary files. Reader and writer are used to read and write character values and process text files. Using the file class, we can deal with files. Right here I have the source, Java application, destination, read, write, and so on. And lastly, this will be the sample code. And this will be, right here is an example of writing a file, creating a new file, using file. Right here, file, my new file. And I will call the file input.txt. Looking at over here, when you want to either write to a file or read a file, you have to make sure that you have these libraries at the top of your code, and that you have the throws exception. Right here I am creating a file, a Java file in which we can write on, and I will call it input.txt. Then I want to write in that file using .write, and writing files in Java is awesome. And then I want to make sure that I close the file. And then next, I want to open the input.txt file so that I can read whatever I wrote inside of it. And you can do so by writing file, my object is equals to new, and the name of the file. And using scanner, we're going to read the file using a while loop, and then we're going to print on the screen the contents of the input.txt file. And at the end, I want to make sure that I close the file. And here is my output. Writing files in Java is awesome. And this is just a basic overview of files input and output. And this will be the end. Thank you so much for watching this video, and I hope that you understood everything.